Hello everyone, welcome to the operating system series. Today we'll be doing the page replacement algorithm. The first one is this is the FIFO page replacement algorithm called as first in first out page replacement algorithm. So what is this page replacement algorithm? In one of the memory management scheme, we do the paging scheme. Well, paging is one of the memory management schemes. So in that particular scheme, we need to bring the pages into the frames. Okay, so in case suppose if the page, a required page, is not found in the frame, then we need to replace that. Okay, we have to bring the page from the disk memory into the main memory, because the main memory is divided into number of frames. Okay, so in case if that page is not found in the frame, we need to bring in the page, and in case if all the frames are already occupied with the pages, we need to just substitute, we need to bring in a page and replace, okay, by that particular. So we need to remove one page from this frame. So what scheme should be implemented? And the scheme should be such that it must have less number of page fault. Now what is the meaning of a page fault? So page fault is suppose if a particular process demands a particular page, we need a particular page for execution of a process, and if that page is not found in the frame, it will generate a page fault. So more the number of page fault, that is a disadvantage. We must have less number of page fault. So there are various page replacement schemes. So one of the scheme is first in first out, okay, page replacement. So in this particular case, we replace the oldest page from the frame. Okay, if there is a page fault, in case if the page field is not found in the frame, we need to bring in another page. For that purpose, we need to replace, we need to just take out the page which is the oldest one. That is, it is called as the first in first out. So let us see an animation and see how much page fault we are getting in that particular case. Okay, now here we have the animation. So let us see how this FIFO algorithm works. So these are the frame. Okay, so here we assume that the frame size is 3. Okay, there are 3 frames. Okay, and we'll see the reference string. Okay, now this is the reference string. As we can see, 0 1 2 3 0 1 4. So this is the reference string. It means this page is demanded starting with 0 1 2 3 and so on. So this is the reference string and this is the frame. Okay, let us arrange this reference string over the frames. Okay, so it means that first 0 is required, then 1, then 2. Okay, so with respect to the first demand, as 0 reference 0 string, that is 0 page is not there in the reference in our frame. Okay, so 0 need to bring from the memory. So there is a page fault. Now this page fault is here in this case is denoted by a star mark. Okay, now next we require 1, but still 1 is not there. We only have 0 in our frame, 1 is not there. So for 1 we need to bring the page. Okay, so there is one more page fault. Okay, then next is number 2. So 2 is also not there. We have 0 and 1, but 2 is not there. So we need to bring in 2. So there is one more page fault. So now we need 3. Okay, but all the frames are already occupied with 0 1 and 2. So 3, we have to bring 3, but we have to replace, we need to just take out one of the page. Now which to take out? This FIFO says that the one which is oldest, now oldest is 0. Okay, it was the first in, so it will go out first. So 0 is the victim. We have to select the victim. So 0 is the victim because it is oldest. So 0 is replaced by 3. So there is another page fault. Now we require 0, and we have 3 1 and 2. So we need to replace the oldest, and as we can see, the oldest is this page number 1. So 1 will be replaced. 1 is the victim page. Okay, so we replace it by 0. Next we want 1. Okay, and in this 302 we can see 2 is the oldest one. So 2 has to be replaced. 2 is the victim. Okay, and is replaced by 1. Okay, next we require 4, and to replace 4, 3 is the oldest in this case. Okay, so 3 is replaced. Okay, 3 is the victim. Now next we want 4. Up to now we have so many page faults. There are about 7 page fault till now. Now we require 0, and 0 is already there, so there is no page fault. Is an advantage. We don't get any page fault in this case because 0 is already there. Next we want 1. and again 1 is already there, so we don't need to bring any other page, so there is no page fault for the two cases. Next we want 2. Okay, now 2, for getting into what we see, the oldest one. Okay, the oldest one here is 0, although 0 was recently used, but because 0 is the oldest one, so 0 will be replaced. Okay, in this case, okay, so 0 is replaced because 0 is the oldest one and is replaced by 2. Next we want 3. Okay, and we see the oldest in this case is 1. Okay, so 1 is replaced. Okay, next we want to replace 4, but 4 is already there, so there is no page fault in this case. Okay, so the total amount of page fault is 1 2 3 4 5 6 7, so there are 9 page fault in this particular scheme. Okay, the page faults are 9. So that's all for this particular session. As you see, there are 9 page faults. Okay, this is how the FIFO algorithm works. So that's all for this particular session. Thanks for watching.